It covers all, this unit covers all kinds of things. It covers, so it's called radical, absolute value, and reciprocal functions. It covers radical equations and radical arithmetic. It covers absolute value algebra, including solving absolute value equations. It covers absolute value functions. It covers reciprocal functions. It covers reciprocal algebra. Like, there's a lot of material in this unit. And we're going to get started today with a lesson that is very closely tied to what you learn in Math 10C. It has to do with basic radical conversions from mixed to entire radicals and entire to mixed radicals. And then we're also going to be subtracting and adding radical expressions, except that if all it was the material you learned in Math 10C, then it wouldn't be in this course. It would be Math 10C. So everything gets ramped up a notch or two here. However, we are going to start off with a basic review of Math 10C. It says convert all of the following from entire radicals to mixed radicals, and we have root 44. And we've already done this in this course because the nature of the quadratic formula makes it necessary for us to do this. And I want to go through two approaches here, and I need you to focus very carefully here. I know that everybody should be able to do this, but there's a bigger picture here that I need to explain. In Math 10C, there are two schools of thought for how you do this. And I want to talk about the school of thought that we probably wouldn't do for root 44. And that's to take 44 and break it down into all of its what we call prime factors. So 44 is divisible by 2. 2 times 22 is 44. 22 is divisible by 2, which means it's 2 times 2 times 11. And this is, again, this is not how I would do this, but it's important you understand this, and you'll see why in a few minutes. That means that the square root of 44 is equal to the square root of the product of 2 times 2 times 11. Now, one of the things that you learned in Math 10C, so this is just kind of rough work on the side. One of the things that you learned in 10C is that the square root of a times b is the same as the square root of a times the square root of b. In other words, if I said to you, what is the square root of 2 times 3? You can figure out that 2 times 3 is 6 and then go square root of 6 and look at a decimal approximation. Or you could take the square root of 2 multiplied by the square root of 3. Just to demonstrate that to you, even though this is 10C we're talking about here. And we'll go with 2 and 3. 2 times 3 is 6, so the square root of 6 is this number approximately. If, on the other hand, I take the square root of 2 and multiply by the square root of 3, well, I get the same number. This is a property of radicals and powers and exponents. Now, how does that help us here? It helps us because we can imagine that there's a multiplication sign in between the 2 times the 2 and the 11. Well, we don't have to imagine, there is. And that means that I can write this as the square root of 2 times 2 times the square root of 11. And the square root of 2 times 2 is 2. And I want us to get this out of the way right now because I didn't teach any of you 10C, so I don't know how this was explained to you, but I don't care what this number is. In this case, it's 2. If I had, well, see if you can figure this out for me. What is the square root of 12.7 times 12.7? No calculator allowed. No calculator allowed. What is it, Sasha? It's 12.7. Now you can try it on your calculator. Take 12.7 times 12.7. I hope you recognize that when you do that, you're squaring 12.7. So the number you're looking at, which I have no earthly clue, I know it's between 100 and 200, but the number you're looking at is what you get when you square 12.7. So when you square root that, you're going to go back to 12.7. What I'm getting at here is that the square root of x times x is x, because x times x is x squared. The square root of x squared simply means you're squaring something and then square rooting it, and those two things undo each other. So what this school of thought, which I'm not a really big fan of for something like root 44 says, you don't even need to do this or this. I know Miss Allen says, I'm sure she explains this, but she says in the end when you look at this is your eyeball, you take out buddies. 2 and 2 are a buddy. They're a pair. And you take out a pair and you write it as a single one outside. And the reason you're doing that is this is a square root. Okay? Now, I prefer to do this a little bit different. If I had root 44, I prefer to just say, what are two numbers that multiply to give 44, one of which must be a perfect square? Well, 4, right? 4 divides into 44, and 4 is a perfect square. And 4 divides into 44 11 times. I hope you see, compared to the other school of thought, that this is exactly the same thing we're talking about. It's just that I'm not consciously thinking of 4 as 2 times 2. I'm thinking of 4 as a perfect square. And the square root of 4 is 2. So we end up with 2 root 11. Very, very basic question. We take a look at root 48, and you use my philosophy. You want to find a number that divides into 48 that is a perfect square. And I think most people's reaction would be 4. Most. Would you agree 4 divides into 48? Let's explore what happens here. 4 divides into 48, I believe, 12 times, yes? Okay. So then the square root of 4, this thing right here, this is 2, so we're left with 2 root 12. But it says simplify. Well, it doesn't say simplify. It should say simplify your result. And maybe that's a good thing that it doesn't, because I want to highlight this right now. In everything we do in this unit, you always want to simplify. Okay? So if I tell you to go get 3 plus 4 plus 5 donuts, you simplify that problem, don't you? You don't go, oh, all right, let's go get the donuts. You keep going until you can't simplify anymore. The simplest way you can write this is 12. Well, in my example here of root 48, this root 12 can be simplified further. There's another number, well, it's the same number, but there is a number that divides into 12 that's a perfect square, and that's 4 again. So this is the 2. This is a 2, and this is a root 3, so you get 4 root 3. 2 times 2 is 4. Are you with me? Okay. Now, with something like this, where we had root 48, how many of you saw the number 16 in there? If you do, then you get there quicker. Okay. So if you said, oh, no, 16 divides in there 3 times, well, that becomes 4 root 3. And look at all of the space you saved and all of the time you saved. But the bigger picture here, everybody, is when you think you're done, always think again. Okay. Now, if you did it using, I'll pick on Miss Allen because I know that she does this, and that's not a bad thing because you need to know how to do this for today's stuff. She would go off on the side and go 48 is, well, I wouldn't always go with 2. Keep chipping away 2, 2, 2. It takes you forever. 6 times 8. 6 is 2 times 3. 8 is 2 times 2 times 2. So what we've got here is 2 times 3 times 2 times 2 times 2. So we have a pair of 2's and another pair of 2's. which means we can take a 2 out of the blue pair and a 2 out of the green pair, and whatever's left over is whatever's left over. Okay, so it's 4 root 6. Sorry. This 2 is not left over. It's 4 root 3. The only thing left over is the 3. Okay? Now this becomes useful because when we look at something like this, and this is new. This is no longer 10c. Well, it might be. You might have done this a little bit. Simplify the cube root of 400. What you're looking for if you do it my way is you're looking for a number that divides into 400 that's a perfect cube. And some of you will be able to handle this, but everybody, what are you going to do when it's 4th root or potentially 5th root? I don't know if I have any 5th roots here, but what if it's the 5th root? I mean, like this one, B, 4th root. Are you expected to know the perfect powers of 4? No. I know that 16 is 2 to the 4, but you probably don't know that. You might. So because as we go from square roots to cube roots to 5th roots potentially, things get more difficult, we use the factoring approach. By the way, perfect cubes are 8 because that's 2 cubed, 27 because that's 3 cubed, 64 because that's 4 cubed, 125 because that's 5 cubed. There's more thought going on here, isn't there? So I would recommend doing this. Let's tear this apart into all of the prime factors. Prime means you can't factor it any further. You're down to numbers like 2, 3, 5, etc. So let's see, 400. I see 400 and my brain immediately says 40 by 10. 40, I see 8 by 5. 10, I see 5 by 2. Now, all of these are prime except for the 8. I'm almost there. The 8 is 2 times 2 times 2. Then we have times 5 times another 2. This is what we have underneath the radical. Now I'm going to take a little pause here. And I want you to use your calculator. I guess I need to show you how to do this on your calculator because you might not know or you might not remember. What is the cube root of 8 on your calculator? How many of you know what the cube root of 8 is? Period, anyway. Okay, that's fine. And this is the point that I'm trying to teach everybody. So on your calculator, you find the cube root function in your math menu on the TI family of calculators. And you scroll down. It doesn't quite look right. I always like to put that 3 like buried deep inside the root, inside that little check mark of 8, and you get 2. Why? Who can explain to me why the cube root of 8 is 2? Like you, Jack, you said you knew it was 2. I saw you do this. Why do you know it's 2?
Because 2 times itself twice, or 2 times 2 times 2 is equal to 8.
Right, 2 times 2 times 2 is 8. In other words, 2 cubed gives you 8. So this is like me taking 12.7 squared and taking the square root. You get 12.7. 2 cubed, take the cube root, you get 2. And what this means, everybody, is that the cube root of anything cubed will give you that thing, right? And what does it mean to say something is cubed? Well, it means this, doesn't it? And if I make it more general, what this statement means is the cube root of r times r times r gives you r. The point I'm trying to make here, and I hope you see it, is that functionally speaking, when you have three identical things because it's a cube root, you extract them, but you only write one. Just like if we have two and it's a square root, you put one outside. So when we go over here, this thing is going to go out as a single item. So it is 2 times the cube root of, what do we have left over? We have 5 times 5 times 2, which is, I think, 50. So let's confirm that the cube root of 400 and 2 times the cube root of 50 are equal. Keep in mind, of course, your calculator is not giving you the exact value, but we know that if the decimals match, they're the same. So I can take the cube root of 400, and then I can take 2 times the cube root of 50. I get the same thing. All right. Any questions with C? Okay, then let's take a look at number 2, I believe we're on now. Convert all of the following mixed radicals to entire radicals. So the difference here, everybody, is if we look at this one, this is what we call a mixed radical, and this is what we call an entire or whole radical. And you know, other than the fact that there's a cube root here, this should still be review of grade 10. In fact, I think there might even be some cube roots in grade 10. So if we have an entire radical, you take out multiple pieces and write them as a single piece outside. For example, with the square root of this, I'll go back to this one. We had the square root of 2 times 2 times 11. We had 2 2's. They went outside and became 1 2 because it's a square root. If we have a cube root, like we have here, then you take out a group of 3, but you write it as a single item outside. So when it goes outside, you get fewer items, which must mean when it goes inside, you get more. If you're asked to simplify 5 root 13 by writing it as an entire radical, then we're simply going to say that that 5 outside must have been 5 times 5 inside. And I just want to stop there. 5 times 5 is 25. Square root of 25 is 5. That's why there's a 5 outside. And then times 13. So we have to multiply those. 325. Thank you, Lucas. So root 325. That's a 5. 3 root 2. Well, this is going to become the square root of 3 times 3 times 2. Or root 18. Again, pretty straightforward. It's just review. And finally, 4 cube root 6 is going to become the cube root of 4 times 4 times 4 times 6. Because it's a cube root, I need 3 of them inside. 384. Thank you. So this is the cube root of 384. Any questions with number 2? So what is going to make things more math 20-ish is the roots are going to elevate from square roots and cube roots to even higher roots like 4th, 5th, 6th, etc. And we're going to have variables. Okay? So this is where the algebra comes in. What we're asked to do is simplify the cube root of 120f to the 5. And then we're also asked, and this is the part that is going to require a lot of thought on your part, are there any restrictions on the variables? See, a variable is a letter that you put numbers in for. And sometimes you're not allowed to put certain numbers in because the math doesn't work if you do. And we'll get to those in a bit. But let's simplify this first. I don't think you can use my method for this. You have to tear things apart into all of the factors. And I realize that some of you can take shortcuts. And what I'm interested in here is you getting the right answer. Okay? So if we tear this down into all of its factors, it's the cube root, and I guess I should figure out what 120 is, right? 120. So this is what you would do as well. And I would probably want to see this on an exam. 120 is 12 times 10. I mean, I think some of us know that 12 is 2 times 2 times 3. I don't think you need to write every little step, but I'm going to. 12 is 4 times 3. 10 is 5 times 2. Before anybody asks, the order that you write these in makes absolutely no difference. And then the 4 is a 2 times a 2. So we have 2 times 2 times 3 times 5 times 2. And if you're like me, and I'm sure some of you don't want to be like me, you should multiply these out to double check to see that you've done it right. Because it's very easy to get extra numbers in there. That's right, though. And then we have f times f times f times f times f. This is what f raised to the exponent of 5 means. So we're going to extract triples. We're going to pull out things that occur in groups of 3. So what do we have? Well, we have 3 2's. So in the next line, those 3 2's will not be underneath the radical sign, but there will be a single 2 outside. And we also have 3 f's. Any 3 that you want, I don't care. So I'm going to have a single 2 outside, a single f outside, and then cube root of whatever's left. So we've torn this all apart. Now we just throw it all back together, whatever's left. We have a 5 and a 3 being multiplied, so that's 15. And then I have 2 f's, which is f times f, or x squared. So the answer is 2f times the cube root of 15f squared. Any questions in getting that as an answer? Okay. Now what about restrictions? Let's play a little game here on your calculator. Are you allowed to take the cube root of a positive number? Of course. Like for example, the cube root of 27 equals 3. You know what? I'm going to choose a different example. The cube root of 64 equals 4 because 4 cubed gives you 64. Are you with me on that? Okay. Are you allowed to take the cube root of 0? Sure, the cube root of 0 is 0. Because 0 cubed will give you that 0. You're allowed to take the cube root of a negative number. It's my poker face. Because I know some of you were saying, yeah, and then you looked at me and went, of course you are. Because the cube root of a number is asking you to find the number that when you cube gives you what you were cube rooting. It's a lot to process. For example, the cube root of negative 125 is asking you to find some number, I'll call it x, so that x cubed gives you negative 125. And the answer here is negative 5, right? Can somebody answer this question for me? Why am I allowed to take the cube root of a negative, but I'm not allowed to take the fourth root of a negative? Will?
There's an even number of negatives in the fourth root, but an odd number in the third root.
That's right. With a fourth root, you're going to end up getting a number that you will have an even number of them being multiplied together. So if I say to you, so ultimately the answer to the question is, if this, it's called an index. If this index is odd, you can take any root you want. But if it's even, you can't. For example, the fourth root of 16 is 2 because 2 to the 4 gives you 16, right? But if I say to you, what is the fourth root of negative 16? I am asking you to come up with a number that if you were to raise to the 4 would give you negative 16. And as Will points out, that's an impossibility because you have an even number of things being multiplied together. All the negatives would cancel. Ultimately, what that means, everybody, in this question is there's no restrictions on f. F can be any number you want because we're taking a cube root. Are you with me on that? Okay, let's try another one. Fourth root of 32m to the 7. So we're going to tear down 32 into all of its prime factors. And we're also going to write m times m times m. Before I go on, how many of you do see how many m's you'll be able to pull out and how many will be left over? A few people, I'm sure. But I'm going to write this out because I'm not teaching to just a few. I'm teaching to everyone. This is going to be a real pain in the butt. So sooner or later, I think it's going to serve you well to see if you can come up with some shortcuts. But I want you to figure out what 32 is in prime factorization. I think it's 2 to the 5, isn't it? 2 times 2 times 2 times 2 times 2. Still working on it, okay? Boy, it sure helps to know your times tables. 32 is 4 times 2. 4 is 2 times 2. 8 is 2 times 2 times 2. So as I said, it's 2 to the 5. I hope that everybody is okay with me writing, instead of writing 2 times 2 times 2 times 2 times 2, or instead of me writing 2 to the 5, I'm going to write 2 to the 4 times 2. Anybody want to enlighten us why I'm doing that? I'm not just rolling the dice and deciding to use that breakdown. Jack?
So it's easier to take it out once you're finishing the factoring?
Yeah, because I have 2 to the 4, exactly, which is 4 twos, 2 times 2 times 2 times 2. And I have a fourth root. And I also have I also have 4 m's, which I could have written as m to the 4 times m to the 3. But regardless, I can take a single 2 out, a single m out, and be left with the fourth root of, what do I have? A 2m cubed. Are there any restrictions on m? A restriction is a rule that says, well, you're not allowed to use this kind of number for m. Lucas, do you know? You cannot have a negative. So what we do is we say this. Instead of saying what we can't have, we say what we can have. M must be greater than or equal to 0. All right, C. Square root of 63 n to the 7 p to the 4. So we're going to tear this down. Well, I don't want to do this. Well, it's not that I don't want to do it. You do it. Break down 63 into all of its prime factors. And if you wish, tear down the n to the 7 and p to the 4 as well. I think that's right, isn't it? Because 63 is 9 times 7. So 9 is the 3 times the 3, and then times the 7. I'm going to write something and then erase it. How many of you are capable of thinking this way? And understand why you would want to think that way. I'm going to caution you that that is very confusing. Even if you understand, it's going to be confusing. I hope that if you do understand that, you understand that you will be writing n cubed outside. Because you have an n for the n squared, an n for the n squared, and n for the n squared. Again, I am of the opinion here, I don't care how you sort it out, you got to get the right answer. So just for the time being, I'm going to write n times n times n times n times n times n times n. There are my 7 n's, and I have p times p times p times p. So it's a square root. It doesn't say it's a square root, but it is a square root. So I can take out the following pairs of items and write each pair as a single item outside. So I'm going to have a single 3, a single n for the first pair of n's, a single n for the second pair, a single n for the third pair, a single p, and again, you certainly don't have to write it that way. You could just go right to the answer. And then what do I have left? I have a 7 and an n. Which gives me 3n cubed p squared square root 7n. Are we in agreement there? Perfect example, by the way, everybody, of a numerical response question where I tell you that root 63n to the 7 p to the 4 is equal to a n to the b p to the c root dn. What are the values of a, b, c, and d? Now, what about the restrictions? Well, clearly n must be greater than or equal to 0. And I say clearly, but I should explain that because you're taking the square root of n. And a square root is an even root. Is there a restriction on p? There is not. But how many of you believe there's no restriction on p because p is no longer under the square root? It's more complicated than that. I want to give you a different illustration. So we're done. And now I'm going to explain to you why there's no restriction on p. If I asked you to simplify this, just that, then you would write the fourth root of p times p times p times p times p times p. So this group of 4 would be extracted. You're with me? And I'm left with the fourth root of p squared, and then I have p outside. Still good? Is there a restriction on p? I'm taking the fourth root. Is there a restriction on p? No. Because it's p squared. So even if p is negative, when you square it, it will become positive, and you're allowed to take the square root of a positive. So if the variable under the square root is raised to an even number, then you can take any root, square, cube, fourth, etc. If it's an odd root, it doesn't matter what the exponent inside is. So it gets more complicated. All right, let's try one more. Convert each mixed radical to entire radical. Well, as we've seen, when you simplify in this direction, anything that is outside gets written inside twice. And I want to be careful with that word twice. When I say, oh, there's two 4x's, I don't mean this. That's not what I mean. And in fact, I probably shouldn't even say there's two 4x's. I should say there's a factor of 4x that occurs twice. So we simplify this now. Underneath, I have what I believe is 48x cubed. Can you double check that? Okay. And x must be greater than or equal to 0 because you're taking the square root of x cubed. If we were taking the square root of x to the 4, that would be okay. J to the 4 times the cube root of j. This isn't difficult. You just have to think. If I put that j to the 4 inside of the cube root, then I'm going to have to put it in 3 times because it's a cube root. Now, I hope that you don't have to write j, 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 j to know that this is j to the 13 underneath the square root. That's where we get the idea of adding exponents when you have a common base. And I made a mistake here that's going to be one that I'm sure you will make, and when you make it, I'll say don't make that mistake. What did I do? What did I not do? Yep. Right, I need the cube root. And I just want to make sure you understand something. I'm sure you do, but you said the 3 in front. That 3 is not a coefficient though, right? It's not that it's being multiplied. I just want to make sure that everybody understands that. So this is the cube root of j raised to the 13. No restrictions on j because it's a cube root. You can take cube roots of any numbers. 2k squared, fourth root 4k. This gets to be a little tedious after a while, but if it's a fourth root, then I have to put 2k squared in as a factor, and I have to put it in as a factor again, and I have to put it in as a factor again, and as a factor for a fourth time. In other words, I have to put in, and some of you might prefer to do it this way, that. If it's a fourth root and I'm putting it in, I have to put it into the 4. And then I also have times 4k. So we can simplify that. If you look here, then you go 2 times 2 times 2 times 2 times 4, which gives me 64, but I think. So it's the cube root. Nope. It's the fourth root of 64, and I get k to the 9. Here, if you do it this way, you're going to get the same result because now you're going to say, what's 2 to the 4? 2 to the 4 is 16 times the 4 is 32. And then I have k to the 2 to the 4, which is what we call in grade 9 and 10 a power of a power, and you multiply those exponents to get k to the 8 times k to the 1. You're going to add the 8 and the 1 and get k to the 9. Any questions with C? All right, simplify if possible. 7 root 5 plus 3 root 5. Okay, so when we say 7 root 5, and I've always said it that way, and I watch videos of other teachers or watch other teachers and observe them, and some of them say 7 multiplied by root 5, and that's absolutely correct. 7 root 5 means 7 multiplied by root 5. But I like to say 7 root 5 plus 3 root 5, and sometimes I will even say 7 root 5s plus 3 root 5s. It's like me having 7 quarters plus 3 quarters, you get 10 quarters. You're adding things that are the same. If I ask you to add 7 kittens plus 3 kittens, you get 10 kittens. If I ask you to add 7 quarters plus 3 quarters, you get 10 quarters. So literally what this means is that we have seven of these and 3 of these. You have 7 root 5s and 3 root 5s. Did I count right? So you have 10 root 5s. The closest thing I can tell you that this is to something you already are familiar with is 7x plus 3x, which you call like terms. You can add them together. 8 root 14 minus 18 root 14 minus 17 root 14 is 1 root 14. If I've been baking chocolate chip cookies and a week after I bake them, they're still good, but because I keep them in the fridge maybe, and I've got 18 left, and I eat 17, other than having a whole bunch of shame, I have 1 cookie left, right? I have 18 cookies minus 17 cookies. I have 1 cookie. Same idea here. And you don't need to write the 1, by the way. You can just write root 14. That's it. Nothing you can do there. That's like me putting on a table in front of you 3 puppies and 10 loonies and saying, what do I have? Well, I have 3 puppies and 10 loonies. I don't have 13. I guess I could say I have 13 things, right? But you understand in high school math, if you said this, that's not going to cut it, right? Do you have 9 things? Yeah, you do, but you can't simplify them. So we can't do anything there. Let's try another one. Can we subtract these? Can we take root 18s and take away root 8s? No. But we can simplify root 18 and simplify root 8. And this is what you're going to be expected to do. I just want to make sure, I hope everybody is okay with simplifying root 18. We don't need to break 18 down into all of its factors. You should know 18 is 9 times 2. Root 8 can be written as root 4 times 2. And I hope you understand that the reason we're doing this is because 9 is a perfect square and 4 is a perfect square. So what do we get? Well, this is 4 times 3 root 2. This is 2 root 2. So we get 12. I don't know why I wrote 3 there, everybody. Root 2. We get 12 root 2 minus 2 root 2, which is 10 root 2. So it turns out these radicals that we started off with at the top of the page were not similar radicals, but we could turn them into similar radicals. By the way, and I speak from experience here, really good students, honor students, want to go from here to here. And you wouldn't believe the number of times I see 36 down here instead of 12. Good students. Skipping steps here can be fatal. Worse yet, I know some of you will want to go from here right to there. If you can do it, that's fine, but be prepared to fail every now and then at that task. Root 18 plus root 32. Well, can we simplify root 18? Well, it's root 9, root 2. Root 32 is root 16, root 2, I think. Yeah. So root 18 is 3 root 2 plus, that's a 6. Looks kind of like a cinnamon bun. I must be getting hungry. Root 32 is 4 root 2. So we get 7 root 2. Any questions with that one? You know, they just progressively get more difficult. Let's simplify these. I would probably argue that many of you would be able to look at square root 4c squared and know that it becomes this. I'm asking you if you can go from the top line to the line I've just written without the middle line. And I suspect many of you would be able to. But what happens is you have two 2's, they come out as a single 2. You have two c's, they come out as a single c. Then we have minus 5, and we will have root 3 times 3 times c times c times c. So we get minus 5 times 3 times c square root c. Again, pair of 3's comes out, pair of c's comes out. So we are left with 2c root c minus 15c root c. And the question is, what can we simplify this to? The hint I would give you is I don't think it's wise to think of this as, listen very carefully, don't think of this as 2c root c's. Think of it as 2 c root c's. 2 c root c's minus 15 c root c's. So you're not thinking of it as 2c root c's. You're thinking of it as 2 c root c's. That's a little greasy. But the bottom line is if I had $2 and spent $15, I would be $13 in the hole, so I would have negative $13. Here we're going to get negative 13 of these c root c's. By the way, we should get in the habit of looking at restrictions. I might have missed a couple, but if there are variables, you should probably write the restrictions. At the very least, if I show you on an exam multiple choice A and it says this, and it also says C is greater than or equal to 0, you shouldn't freak out over that. You should know what it's about. It's just telling you there's a restriction on C. And the last one, nope, second to last one, 2 root 98. So we have a whole bunch of simplifying to do. You have to simplify root 98. You have to simplify, if you can, root 10. You have to simplify root 8 and simplify root 40. So root 98 is root 49 times root 2. I'm pretty good with my perfect squares. You're going to have to work around that somehow on your calculator. The bottom line here, everybody, is by hook or by crook, which means I don't care how, as long as you're not just looking at somebody else's work. You need to know how to turn root 98 into 7 root 2. I mean, you got to know how to do it. And I'm not going to teach you elementary or junior high number math with this. You need to figure it out on your own. Root 10. Oh, root 10 is root 10. You can't do anything with that because 10 is not divisible by any perfect square. What do we have? I guess I'll put it up here. I'm on the wrong line. Minus 5 root 8. Root 8 is 4 times 2. Root 4 times root 2. Minus 3 root 40. Root 40 is root 4 times root 10. How many of you see how this is going to start coming together? Some of the terms are going to be similar. How many of you might have, for this one right here, just written 14 in the next step? Be very careful because, again, I see people do that here, and I see so often people write 20. But it's not, because root 4 is 2. This is minus 5 times 2 root 2. And this is minus 3 times 2 root 10. And maybe all I'm trying to get at is it's really easy to make mistakes. You can understand exactly what it is you're supposed to be doing, but you make these little mistakes. What do we get? 14 root 2 plus 1 root 10 minus 10 root 2. I'm multiplying these numbers that are not part of the radicals. 3 times 2 is 6 minus 6 root 10. So 14 root 2's minus 10 root 2's is 4 of them. And then root 10 minus 6 root 10 is negative 5 of those. Any questions with that example? All right, cube roots. Just a curiosity thing. How many of you do you think are comfortable just looking at perfect cubes? Maybe. If you are, then you can proceed in that way. Like 8 goes into 16. 8 is a perfect cube of 2. 27 goes into 54. 27 is 3 cubed. I don't think most people would buy that very easily, so I'm not going to do that on the board. Cube root of 16 is 2 times 2 times 2 times 2 underneath the radical sign. By the way, this thing that's under the radical sign is called a radicand, and we'll use that word more often later on. 54. 54. Oh, that's my white whale. Is 54 9 times 6? No. What is 54? It is 9 times 6. Okay. It's the one, how many of you have a hole in your times table? That's the one you look at and you go, I don't know what it is. What's yours? That one, eh? Yeah, I don't know why. I look at this one and I go, there's something about it. Anyway, 9 times 6 is 3 times 3. That's my 9. 6 is 3 times 2. That's my 6. So I can write this as 2 cube root 2 plus 5 times 3 cube root 2. I'm pulling out triples, and whatever's left is whatever's left. So I have 2 cube root 2 plus 15 cube root 2 gives me 17 cube root 2. And that's it, I think. That's the last example. Okay, so you have a fair amount of time here, about 25 minutes. I might hand back your exams here so you can take a quick look at them. Okay. By the way, if you are going to be rewriting, if you want to rewrite, same thing as always, you need to send me an email. If I don't get an email from you, doesn't matter if you talk to me in the hall or in class, go, hey, can I get a rewrite? I'll say to you, send me an email. And until I get that email, we can't pursue it any further. Rewrites would be Thursday of this week after school or Tuesday of the following week after school. Okay. Page 278, 1 to 5, and 8 to 10, and I'm saying page 304, 1 to 5. I don't know if it says this on your handout. That's extra. It's, I would say a bare minimum, if you want to be fair with yourself and honest, are the questions on page 278. So I'll let you get started. I got to take care of my attendance and a couple of other things, and then I'll come around and help you out.